Hello everyone, welcome to our channel Mathematics Parshala, and this is another problem on CSIR UGC NET June 2023 and 704090 is the question ID, and this is another problem of topology. See the question here, x equal to pi n equal to 1 to up infinity 0 1, that is the space of sequences xn with xn belongs to 0 1 n greater than equal to 1, and the metric d from x cross x to 0 infinity is defined by this sup metric, and then which of the following statements are correct? Metric topology, number 1, metric topology on x is finer than the product topology on x. Metric topology on x is coarser than the product topology on x. The metric topology on x is same as the product topology on x, and the last one is the metric topology on x and the product topology on x are not comparable. See here, 0 1 is the subspace of the usual topology on R. So we will see 0 1 as the subspace with respect to the usual topology on R. So this is the countable infinite product of the 0 1, which is the subspace as the usual topology on R. And we now show that the metric D is defined here in this way, and we now show that the topology induced by this metric will be the same as the product topology on X. So we now show that the product topology on X and the metric topology on X will be the same. So our option 1, 2, 3 will be correct and option 4 will be false. So let us now start to show this, and before starting we need to write important result which will help to serve our purpose. That suppose X is a non-empty set and tau 1, tau 2 are two topologies on X, and script B1 and script B2 be the bases for the topology tau 1 and tau 2 respectively. For the topology tau 1 and tau 2 respectively. That means beta 1 generates tau 1 and beta 2 generates tau 2. Now the theorem is about to the comparison of tau 1 and tau 2 with the help of their bases. So now tau 1 will be subset of tau 2, that means tau 2 will be stronger and tau 1 will be coarser if and only if for any B1 belongs to script B1 with X belongs to B1, there exists a member, say B2 belongs to script B2, such that X belongs to B2 subset of B1. That means if we take any basic open set B1 and any X here, then we can find a basic open set B2 from script B2 such that X belongs to B2 is subset of B1. If we can do that, then we will say that tau 2 will be the stronger topology than tau 1. So this will be a important result which will be used here to show that, because we now show that the product topology and the metric topology will be equal. So let us now denote the metric topology by, let us now denote the metric topology by tau d and script bd with the base for tau d, and we denote product topology by tau and script b for the base, which is the base for tau. So this will be our notation, and what we need to show is that tau equal to tau d. Then our problem will be solved. So to show tau equal to tau d, we first show that tau d subset of tau, and then we show that tau subset of tau d, then it will be equal. So first, to show tau d subset of tau, we need to take a basic open set in the product topology tau. Sorry, we need to take any basic open set for the metric topology tau d. So let us take an open set B belongs to script BD, which is the base for the metric topology tau d. So clearly this B, since this is a basic open set in the metric topology, so this B will be of the form B equal to, say, BD x epsilon for some positive epsilon greater than 0. Now choose n large enough such that such that 1 by n less than epsilon. We can choose such n by Archimedean property. Now let us take V equal to, say, x1 minus epsilon comma x1 plus epsilon open interval Cartesian product x2 minus epsilon x2 plus epsilon dot dot up to, say, xn minus, for this n, xn minus epsilon xn plus epsilon, and the other product will be same as 0 1 cross 0 1 dot dot. So first we have taken a B belongs to script BD with x belongs to B, x is our sequence xn. So first we have seen that this basic open set will be of the form BD x epsilon for some epsilon greater than 0, and then we have chosen an n such that 1 by n less than epsilon, and we have taken a set V equal to this. So we now show that x belongs to V is subset of this BD x epsilon. So clearly this x belongs to V. This is very clear because this x equal to xn, and x1 is here, x2 is here for these coordinates, and after nth coordinate this 0 1 will be the in the product. So clearly x belongs to V, and we now show that V is subset of BD x epsilon. For this, let us take an y belongs to V. So this y equal to our sequence yn. So clearly our y1 belongs to, in the first one, x1 minus epsilon comma x1 plus epsilon. Second one, y2 belongs to x2 minus epsilon comma x2 plus epsilon, and up to yn belongs to xn minus epsilon comma xn plus epsilon, and the rest elements yn plus 1, yn plus 2 dot dot all are belongs to closed interval 0 1. Now see, for the first n coordinate, first capital N coordinates, yi belongs to clearly xi minus epsilon comma xi plus epsilon. That means our mod xi minus yi less than epsilon. for all I less than equal to n, and also 1 by 2 to the power I mod xi minus mod yi less than epsilon by 2 to the power I less than epsilon for all I less than equal to n. And then for I greater than n, we will now calculate. So for all I greater than n, see 1 by 2 to the power I less than 1 by I less than 1 by n. And also, since this xi, yi are taken from closed interval 0, 1, because all coordinates are taken from open interval, closed interval 0, 1, so our mod xi minus yi will be less than equal to 1. So for all I greater than n, 1 by 2 to the power I mod xi minus yi will be less than equal to 1 by 2 to the power I, and which is less than 1 by n, which is less than 1 by n. And also we have taken n such that 1 by n less than epsilon. We have taken so n such that 1 by n less than epsilon. So here this 1 by n less than epsilon. So see, first we have calculated for any I less than equal to n 1 by 2 to the power I mod xi minus yi less than epsilon, and then we have seen that for all I greater than n also 1 by 2 to the power I mod xi minus yi less than epsilon. So what we get, that for any I belongs to natural number, for any I, so I greater than equal to 1 mod xi minus yi by 2 to the power I less than epsilon, and this is our dxy by the definition of d. So dxy less than epsilon, so our y belongs to this, that means bd x epsilon. So see again that we have taken y, we have taken any y belongs to v, and what we get, that this y belongs to bd x epsilon, and also our x belongs to v. So merging this, what we have get, x belongs to v subset of bd x epsilon, and this we have taken as any basic open set B from our metric topology. And see also the structure of our V, we have taken our V as, see, this is the structure of our V. See, the first coordinate is open set in closed interval 0, 1 as the subspace topology. The second one is open set in the closed interval 0, 1 as the subspace topology, and this is also an open set in closed interval 0, 1 as the subspace topology, and the rest are the whole sets. And we also know that any basic open set in the product topology is of the form, there are finitely many open sets in finite indices, and the rest will be the whole sets. So this is clearly a basic open set in the product topology. So what we have done, we have taken an basic open set in the metric topology, and we get a basic open set V belongs to our script V, which is the base for tau. So this implies by our result stated above that our tau is the larger topology. So tau d is subset of tau. So one part is our done. Now we will show the second part. Now we will show tau subset of tau d. So for this, we now take any basic open set in the product topology. Let U belongs to our script B, that is the base for the product topology, with our x belongs to U, and we now show that there exists an basic open set V belongs to script BD such that X belongs to V subset of U. This we need to show. So now see that we have taken U, a basic open set from the product topology, and now we have just stated that any basic open set in the product topology is of the form U equal to pi UI, where UI are open for finite indices. Say UI is open in closed interval 0 1 for say I equal to alpha 1 alpha 2 up to alpha n, and the rest UI will be equal to the whole space, that is closed interval 0 1 for all I not equal to in this form alpha k. So we need to show what, that an basic open set V belongs to BD, V belongs to script BD such that X belongs to B subset of U. See here, UI is open UI is open in closed interval 0 1 for I equal to alpha 1 alpha 2 alpha n, and also our X belongs to U, that means our xi belongs to ui, and since this ui is open, so each xi is interior point, so there exist for each I equal to alpha 1 alpha 2 alpha n, there exist say alpha I greater than 0 such that xi belongs to xi minus epsilon I comma xi plus epsilon I is subset of ui, because this ui is open in the usual topology in closed interval 0 1 as the subspace topology of R for I equal to alpha 1 alpha 2 dot dot alpha n. Now let us take epsilon as epsilon equal to minimum of this epsilon I by 2 to the power I for I equal to alpha 1 alpha 2 dot dot alpha n. So this is minimum of epsilon 1 by epsilon alpha 1 by 2 to the power alpha 1, epsilon alpha 2 by 2 to the power alpha 2, and so on up to epsilon alpha n by 2 to the power alpha n. And we now show that x belongs to this BD x epsilon subset of our this U. So then we tell this BD x epsilon equal to our that V, which we need to find. We now tell this BD x epsilon as our required V. So we now show that first. So clearly this x belongs to BD x epsilon, this is very clear. So we now show that BD x epsilon is subset of U. So for this, let us take an y belongs to this, let an arbitrary y belongs to BD x epsilon. So our dxy is less than epsilon, that means our sup 1 by 2 to the power I mod xi minus yi I greater than equal to 1 is less than epsilon, and so that means our 1 by 2 to the power I mod xi minus yi less than epsilon for all I. And also by the construction of epsilon, it is very clear that this epsilon is less than equal to each epsilon I by 2 to the power I for I equal to alpha 1 alpha 2 up to alpha n. So we get from this and this mod xi minus yi less than epsilon I for I equal to alpha 1, alpha 2 dot dot alpha n, and that means our yi belongs to open interval xi minus epsilon I comma xi plus epsilon I, and that is also subset of ui for also I equal to alpha 1, alpha 2 up to dot dot alpha n. And see, now here our y1 belongs to this u1, y1 belongs to I equal to alpha 1, alpha 2, alpha n. So our y alpha 1 belongs to our u alpha 1, our y alpha 2 belongs to our u alpha 2, and dot dot our y alpha n belongs to our u alpha n. And see, in the definition of our u, when I not equal to of the form alpha I, then others are ui equal to close interval 0, 1. So since here y alpha 1, y alpha 2 up to y alpha n belongs to here u alpha 1, u alpha 2, u alpha n, and rest are close interval 0, 1. So clearly the others yk will be close interval 0, 1. So our y will be in this product ui, and that is equal to our u. So we have taken an arbitrary y belongs to bd x epsilon, and we get this y belongs to u. So what we get? We get this bd x epsilon is subset of u, and also clearly this x belongs to here. So this bd x epsilon, we say this v equal to this bd x epsilon is clearly a basic open set in the metric topology. So we have taken a basic open set in the product topology, and we get a basic open set v in the metric topology, which is subset of that basic open set of the in the product topology. So our metric topology will be larger. So tau, which is the product topology, is subset of tau d, which is our metric topology. So by the previous one, with this we get tau equal to tau d. That means the product topology will be is equal to the metric topology induced by our this given metric dxy equal to sub mod xn minus yn by 2 to the power n. So our here option 1 metric topology is finer than the product topology. Finer means also may be equal. Option 2 metric topology is coarser, that may be also equal, and the metric topology is the same as the product topology, which now we have proved. And option 4, they are not comparable, is the not correct option. So option 1, 2, 3 is the right option. Thank you for